if you're using App Engine and you have questions and problems, you cannot take the telephone and call an engineer on the App Engine team, but you can talk to me and then I can talk to them. Okay, so I'm like your agent and I'm like their agent too, because they don't go out and give talks. Because they're nerds! Okay, so you have to have somebody who's technical as well as can have good communication skills too. So it's a very tricky job I have. So, okay, so today I'm going to talk about App Engine and I'm going to go through as many slides as I can. Alright, so let me just set my timer so I know. Alright, so how many people here have played with App Engine before? So, about so. Okay, how many people use it to make a living, to earn money? Oh, okay, everybody talk to her. Okay, alright. So we want more of you guys because we think it is something that you can use to run your business. Alright, so a little bit more about me. I'm a software engineer. I actually don't do as much engineering as I used to anymore because I have this job now. So this job is half an engineer and then half, public relations. My background in software is I was one of the original engineers on Yahoo Mail. There were about like eight engineers altogether, and we built the whole thing in about 6 months using almost all Python and C++ in the back end to do the mail store. But it was 14 years ago, so a lot of people did not know Python back then, but we did use mostly Python to build Yahoo Mail. And then Yahoo bought a little small company, and that's why it became Yahoo Mail. But I also worked at other big companies like Sun, HP, EMC, and Cisco. I also like to write and teach, so you may have seen some of my books in the Python community. So I like to do that. I like to talk. I'm also going to Python Brazil, so if you guys want to practice your português, then feel free to come up. Okay. All right. So before I talk about App Engine, let me talk about cloud computing. Okay, because that's a big phrase. Those two words mean lots of different things to different people. So let's talk about that first. So this is the NIST is a U.S. American government institution that defined cloud computing. You don't have to read all of this because there's a lot of long English words. But what it really means is there's a shared pool of computing resources. So network, machines, hardware, software that you can actually get really quickly and then you can release really quickly. So you don't have to buy it and own it. You can just use whatever you need and then you finish with it as something that's shared and you can access from the network. So that's the main idea of what it is. So a long time ago, in 1984, at Sun, they had this phrase, the network is the computer. Now, that makes a lot of sense now, today, but back then, the computing was not cheap enough. It was still too expensive to make cloud computing happen. And it didn't really start until Amazon. Everybody buy books from Amazon, right? So the reason why, or how they started, they made cloud computing happen is because, can you imagine how much hardware and how much equipment and storage they have in order to survive, shopping for Christmas, right? Think of all the people that are buying, right? So they have all these machines. What are they doing right now in Julio, or 2 months ago? What were they doing? Sitting still, right? They were not using all that equipment. So it cost them so much money, they said, oh, let's rent it out and get some money back for it. And that's how it really kind of all got started. And then other big companies like Microsoft and Google said, oh, we're going to do that too, because we have a lot of computers. We want to rent them to people too. All right, so that's how cloud computing really got started. So the main idea is you don't have to pay for a lot of administration because you're renting. You are outsourcing this the computing power. It's elastic, which means you can expand your usage and you can shrink your usage. It's automated, it's flexible. There's a lot of good things. The main idea is so that you only have to worry about the solution you're trying to build, to try to make money. You don't want to be like the entire company, be a system administrator, so that you can manage all the systems. So that's the main idea. And then, so there's this other company that does, the industry analyst says by next year, 1/5 of the largest 2,000 companies in the world will be using some sort of public cloud service, okay? And it was only 5% 2 years ago. So we'll see next year whether they hit that target. All right, so this is another graph from another analyst company, Gartner. So they define cloud computing in 3 categories. SaaS is software as a service. So that is where you have an online application that is only available online. You have to have a web browser to use them, like a Gmail. Gmail, Yahoo, Hotmail, you have to have a web browser to use those, right? You can't, there's nothing to download on your computer except for your browser, all right? So, and Salesforce, all of these other things, you have to be online to use them. So those are software as a service applications because you cannot, if you don't like them, if you don't like Yahoo Mail, Hotmail, or whatever, you cannot change them. They're not under your control, okay? So, any application you have to have online access to get to that app is called software as a service. On the bottom layer is IaaS, infrastructure as a service. That means you're renting machines, storage, power, cooling, networking. This is the very basic things that you need for computing. And then you're responsible for everything else above that layer. So operating system, web server, database server, load balancing, networking, monitoring, all of that stuff you are responsible for if you do infrastructure as a service. With software as a service, you don't worry about any of those things at all, right? When you log into Yahoo Mail, you're not thinking, oh, I hope Yahoo servers are not really crowded today. You don't think, oh, you know what, I have to upgrade my Gmail operating system. Now, you don't think about those things because they're not your problem. All right, but if you do infrastructure as a service like Amazon Web Services and VMware and Rackspace, you do have to worry about those things, okay? So now the middle one, I think, is the most powerful one, okay? Because this one is called platform as a service. The reason why I think it's powerful is because you get all of the features of renting the machines and the hardware, but you don't have to worry about those other hard things like operating system, database, load balancing, networking, those things you don't have to worry about. You get those for free. And so that's better than infrastructure. It's also better than software as a service because you can control the source code. It's your source code. All right. So you're not like, oh, I'm using Google spreadsheets and I don't like it. I want to fix it. I want to add features. So you can't do that. Platform as a service does let you write your own application and it hosts it in the cloud using all of these infrastructure things, but you don't have to worry about these other things that don't have anything to do with your application, right? The database server, the web server, those things are independent of the application. You need them, but they're not related. So, using platform as a service, you are leveraging the power of infrastructure as a service to be able to build software as a service applications. That's what you're really doing. When you're hosting your app in the cloud, your app is actually a software as a service app. Comprende?
Yes.
Okay, good. So now you understand all 3 layers. Okay. So that's why I say, of course, my opinion might be biased that the middle one's the most powerful one, but that's my opinion. So, okay. So why does App Engine exist? Why did Google create this? Because of all those reasons I told you about earlier. Operating system, web server, database. I didn't even mention like logging and configuration, and money. Okay, it costs money to run all that stuff yourself. There's all these things that you have to worry about, all in addition to your app. So you have your app that you have to worry about, then you have to worry about all these other things. Okay, so that's why they created it. Okay. So App Engine is easy to start because there's always a free quota, free tier that you can always try. Easy to scale, that's the best one because you don't have to do anything at all except for maybe a little minor adjustment to your configuration. And then easy to maintain. So it's very easy to develop your code, it's very easy to update your code, and you can choose which version of your application you want to run. So like if you uploaded a new version and it's broken, you can actually roll back pretty easily to the previous version because we keep those. You don't have to go and go to your source code repository and go, oh, I got to get all my files for the old working one. Okay, so we do maintain that. The main idea is, I don't know, como se dice, pagers, beeper. You guys have those? So we have a team that worries about the system so that you don't have to. You can sleep. Even if famous celebrity tweets your app or something, your app's not going to go down. Okay, that's our problem, to keep your app up, not yours anymore. So you focus on your app, and you don't have to be a sysadmin. Okay. All right. So now let's talk about the pieces of App Engine. 4 main pieces: runtime support, software development kit, administration console, and then infrastructure. So we will start with the one you don't have any control over, and that's the infrastructure. So this is all custom-made Google hardware. It runs some sort of Linux. It uses the Google file system, which is our own file system. It uses Bigtable, which is the Google non-relational database. And then, of course, custom hardware as well. So these things you have no control over, but that is what your stuff is running on, because the rest of the company runs on the exact same thing. Okay? So your app is actually going to run in the same data centers on the same machines as all other Google services. Google Maps, the ads, search, everything. Okay? They're all together. So language runtime. So we support 3 languages: Python, Java, and Go. These languages are pretty much batteries included. Well, mostly Python and Java, because Go is still very new. Batteries included means it has everything you need to be able to, almost everything you need to be able to do an application. There's also additional runtimes because we do have a Java JVM, so I'll talk about that on another slide. All right, so the reason why Python was picked is, well, one reason was Guido is on the App Engine team. Okay, so that's pretty easy. But you guys know, you guys already know that you can develop very fast. You don't have to have a computer science major to use Python. Very, very easy to use. People can pick it up very quickly. So it's the king of ease of use. Java was picked 1 year later because it's the king of enterprise development. So it's everywhere, anywhere there's enterprise stuff. All right. We tried to follow the Java service standard. In fact, we try to follow as many Java standards as we possibly can. Of course, Java has a rich library of packages and modules just like Python. There's also Eclipse support. So if you are a Java programmer and you use Eclipse, Google has a custom plugin that you can use to help you with your App Engine app. If you are a Java developer and you like NetBeans or IntelliJ, they also have plugins. They're just not maintained by Google. And of course, there's other languages which I'll mention coming up very soon. And then Go is the new one. So we just announced this a few months ago at Google I/O. So it's sort of like a combination of Python and Java, believe it or not. It has the same ease of use as a Python, but it has more of a statically compiled type of language like Java. And one of the best things about Go is that threading is actually built into the language, so it's actually pretty cool. You should try it. It's a good alternative to Python and Java. All right, so for Java developers, like I said, we try to stick to as many Java standards as possible. So whatever you know about Java standards, there should be an equivalent API on the App Engine side. So we try to make it very easy for Java developers to move into developing for App Engine. So I mentioned that we support other languages, and this is because we have a JVM. So you can actually run Scala and Ruby. You can also run Ruby using JRuby, PHP using Quarkus, JavaScript using Rhino, and of course you can also do Python running Jython. And usually, there are a lot of Java developers always ask me, well, why would I want to write it in Python and run it on Jython when I can use the pure Python API? The main reason for that is if you spend a lot of time and energy building all of these Java classes, you don't want to rewrite everything to Python, but you want to put your new stuff in Python, well, go ahead. You put the new stuff in Python, you run them both using Jython, and your Python objects on top of your Java objects, because everything's a JVM, right? So it's a really good way to kind of like have shared code. All right, so that's the main use case for using Jython. All right, so web-based administration console. So I will mention in a little bit how if you're in cloud computing, your application is going to run on the same machine as other people. So I don't know if you trust the person sitting next to you, but I don't know if you want them to be able to access your app and data, and I don't think they want you to access their app and data. So everybody runs on shared machines, and so because of that, we have to have really good security. And security means you run in a sandbox, and when you run in a sandbox, you lose a lot of control. Right? You don't have access to all of your logs. You don't have the ability to write monitoring code and all that stuff. So we try to build this stuff for you. So, so Google created an App Engine administration console or a dashboard that tells you everything you need to know about your app, or almost everything. So it gives you a graph to show you what kind of traffic you're getting. You can also find out how fast your app is responding. You can find out how many errors per second your app is getting. It also tells you like how close you are to your end of your free quota, or have you gone over quota. It tells you how much money you have budgeted and how much it's cost today. So all of the data resets every day, so you can actually see how you're going. And you can adjust it. You can change your billing settings. You can take a look at your objects that are in your data store. You can set permissions on who else could be developing on the app and who can update it, things like that. It tells you how many errors there are. It tells you what are the most current URIs that are being hit on your app. So, so it just tells you lots of different data. You kind of see in this picture that this app is getting a little bit of traffic. The number here is about 0.6, so about one request every other second. So it is actually getting some traffic, so that's not too bad. If you have a request hitting your app once every other second, that means a good number of people know about your app already. Okay, so a little bit more about traffic later. Okay, so the next thing is the SDK. So the software development kit, it's open source, client-side code that you download, and you write all your code using these client APIs. And then when you upload them to Google, it'll talk to the server side. It also comes with a development server, so you can actually run locally. Okay, so you can actually test and debug everything before you actually upload it to production. They're very easy to deploy. It's either one click or a command line. You just type in your username and your password. You can manage all your versions. And the SDK comes with a lot of all the client-side APIs, which I will talk about coming up soon. Okay. So before we get to actually talking about App Engine, let's talk about some of the users that we have, some of the uses, some of the case studies. The reason why I tell you this is because some people think, oh, App Engine is like cheap hosting. Okay, so that's not the main goal, because you can always go get a cheap PHP monthly host, right? App Engine was not made for that purpose. That's why it costs a little bit more than cheap PHP hosting. Okay. Well, right now, because we're still in our preview period, it may be cheaper than PHP cheap hosting. Okay. But once we become an official product, then the prices will be more in line with all the other all the other companies that are doing similar services. Okay. So App Engine is 4 years old, 3 years old. It's on the 4th year now. So you can see the traffic, the usage has really grown. We're also adding a lot of features every year. Okay, so we don't stop development on it. We're always adding new features for people to use because they want to be able to build more powerful applications. So we're always adding new features. Okay, this is just a small list of what they are. So you can see we have a lot of user growth. So how many users do you think we have? Okay, usually when people ask, Google questions like, so how many users do you have? Google goes, I'm sorry, we can't tell you, that's confidential. Okay, so usually we can't tell you numbers, but there are some numbers I can share with you today. There are over 100,000 active developers every month. So that means we have these users are either logging into the administration console to see how well it's doing, or they're uploading another version of their app. They're basically active. Their app is very active. Okay, they're doing things with it. Okay, 100,000. How many apps are there? There are more than 200,000 active applications every week. Okay, so we went from month to week now. 200,000 every week. That means you're getting traffic. So this is not the Hello World tutorial that you did and then no one's using it. These are real apps that are actually getting traffic on a regular basis. Okay? Alright, so I'm going to ask you guys to guess. If I were to put all of the App Engine apps together in the entire system around the world, how many page views a day do you think the App Engine system serves? All apps. Guess? 1 billion? Now a little bit more. 1.5. Very close, 1.5. So, of course, these are numbers we can tell you, but the real numbers are going to be a little bit bigger. Okay? So there's definitely more than 1.5 billion apps, page views every day. So we went, we had 100,000 developers every month. We have 200,000 active apps every week. And now we have 1.5 billion page views every day. Okay, so that gives you an idea of the scale of the system. All right, and I'll give you more ideas of scale pretty soon. Okay, so here are some well-known companies that use App Engine. They're not all American companies. Many of them, of course, are American companies, but there's some like, let's see, like Giga. They're based in Israel, and there's Japanese companies. So it's actually used around the world by lots of different companies. All right. Let's see what else. All right. So so App Engine scales pretty well. So that's one thing I'm going to focus on. So in the previous slide, I said developers who know that App Engine scales for social web and mobile apps. So BuddyPoke, so let me just go back. So I'm going to talk about this one, BuddyPoke, and this one, Giga, today, just as examples, and then a few others. Okay, I think I'm going to mention FastFind, but find these two. So this is a social networking thing. So if you have a Facebook or a MySpace account or Orchid account, BuddyPoke is it has an icon. You have an avatar. You can share with your users. You can play together. It's kind of fun, right? Games that people like, teenagers like, young people, right? So what kind of scale does this type of app have? Well, this application has more than 64 million registered users, which means that there's more than 64 million objects in their data store. Okay. But usually registered users doesn't tell you the whole story. Other things that are more important are like how many daily active users are there. So that means people that come and use the app every day. So there's like 3.6 million on Facebook, 1.9 million on MySpace. So it's about 5.5 million people using this app every day. Okay, so that's one kind of scaling that we have. And those don't include all the other social networks that are out there. So Giga is another company that that uses App Engine, and their scale is a little bit different. What they do is they make apps for specific events, like a big football game or a Hollywood movie promotion, or President Obama town hall or something. They do special one-time events, and so this is the type of scaling that they have. So remember how we looked at the dashboard for the app on the previous slide, where it shows, oh, you're getting about 1 request every other second, so about 0.6. If you look at these numbers, it's much more larger. So this is 400. Okay, so this is an event, probably one of the Obamas, or maybe it's an Oprah thing. So it goes around nothing, and then the news gets it, and then the traffic goes to 400 requests every second. 400 web browsers hitting this application every second. And then it keeps on going up to 800, say the 800, and then the event starts. And then it goes all the way up to about 1,600 requests per second. And then the event ends and then it's over. Okay, 1,600. Let's see how you say that. Seiscientos. Yeah, 1,600. Great, thank you. Every second. Okay, so that's the kind of scale that you get. Your cheap PHP hosting is not going to give you that scaling. Okay, so that's very important. It's crazy. And of course, the wedding. Okay, big wedding. So the blog app was hosted on App Engine, and so on the wedding day, they got 2,000. So we talked about 1,600 was a lot. 2,000. 15 million page views, 5.6 million visitors. So that was done by an outside company that used App Engine. That was Accenture. It's a big consulting company. But internally, YouTube also wrote an App Engine app, the live stream. They got up to 32,000 requests per second on the wedding night. Who stayed up late? All the ladies. Yes. Yeah. Okay. 32,000. And then when they did the Bezos, it went up another 10,000 to 42,000 requests per second because people, oh, you gotta watch. So, they could agree with it. So, 42,000. Can you imagine that? That will take your machine down so fast you would not believe it. Okay. So if you want to read more about what their App Engine app did, you can read more from this link, and then you'll have the slides because we'll upload them to the PyConAr website. So another one, which is not as exciting as the wedding, is big American companies have to report their financial information to the government every quarter. And so can you imagine how exciting that is? putting their Excel spreadsheets together with all these numbers, are they real numbers or whatever? So all these big American companies, and so that's really boring, right? So what they did was they created a Flash-based app in the cloud where they can just drag and drop their files, it organizes everything, it fills out all the reports, and it uploads it to the government. So they're making a lot of money. So big companies are depending on web filings. Web filings is depending on app engine. Okay. And of course, if something goes bad, then they call us, and they're really mad. Like, fix this. Okay, so we have to make sure that they're happy because they have very important customers. So all the apps I talked about so far are user-facing. They're like web-based apps. But there's another use case which is very popular, which is non-user-facing, right? Like apps that run on mobile phones. Okay. The same thing applies. If you want to have a back-end server, you have to build it yourself, host it yourself, do all those things, or you can also do it with the cloud using App Engine. You don't have to have a user interface as long as you talk HTTP, as long as the mobile phone can make an HTTP call, it can talk to an App Engine app. You can store all the important information like your high scores for your games, all your friends' contact information, your level, your badges, all the things that you get from playing a game because you may have your mobile phone today, but tomorrow you may have an accident in the toilet. Okay? And if you go to the store and buy a new mobile and you lost all your high scores, you're going to be upset. You're not going to be happy, right? So you want to give your users a better experience by putting all this information in the cloud so that when they get a new phone, they can download, it'll automatically download their high scores and their levels and all that kind of stuff. In fact, you even can let them go look at their high scores on the web browser at home. You're not restricting them to have a phone. What if it's charging downstairs, right? Okay, so this is a good use case too. Back-end processing that has no user interface, but your user interface is somewhere else, like on a mobile phone. And of course, we'll have a lot of games that use App Engine as well because of that. Okay, so that example is actually a real example. Okay. All right, so now let's talk about what's in App Engine. Okay, so I mentioned earlier you have to execute in a sandbox. Okay, it has to be a controlled environment, very secure. So because of that, there's some things we don't allow you to do. You cannot open a local file, you cannot make an operating system call, and you cannot open a socket. Okay? But if it's a web app and you can't open a socket, then that's pretty useless, right? It can't do anything if you can't talk to the outside world. But why do you want to create a socket? The reason is because you want to do something like send email or call another web program that's somewhere on the internet, right? So instead of giving you the ability to create sockets, we are giving you higher level APIs for what you really want to do, like send email. Okay, so your App Engine app can send email, and it can also receive email. So you can actually auto-process email using an App Engine app. Same goes for instant messages or Java or XMPP, right? So you can make your App Engine app send instant messages as well as receive instant messages. So you can make people think they're talking to a real person, but they're really not. Okay, can you imagine? Lots of applications for that. You can talk to an outside outside program on the web. Okay, as long as you have a URL, you can do that. There's also a data store. It's distributed. It's highly scalable, but it is expensive. You don't want to touch your data store very often, so that's why we also give you memcache. So if you have data that's accessed all the time, don't go to the data store to get it all the time. Cache it. Okay. So the other restriction is we don't want you to take up all the resources on the machine. So your application cannot run longer than 30 seconds. When a user request comes in, you have to respond in less than 30 seconds. In fact, we recommend that your response is less than 100 milliseconds. The faster your app responds, the more App Engine scales for you. The slower you are, the less resources we'll give you because you're taking up too much time. So if you have something that takes longer, okay, or you just don't want to take time and you just want to send a response right away, then you can do background tasks using the task queue. You can just fork off a task and let that run in the background, and you respond back to your user right away. Okay, so task queue, so 30 seconds is the deadline. For task queues, the deadline is 10 minutes. Okay, so if you have longer, you can run a task queue. If you need more than 10 minutes, then we have another service called Backends that lets you just have a long-term running server. Images API is not very exciting. It just lets you rotate, crop, and resize images. Blobster is if you have to serve media files. So you can upload media files as big as 2 gigabytes with Blobster, and then we also provide authentication too. Okay, so you can roll your own authentication, or you can require your users have Google accounts, or you can also use federated login, which is like OpenID. So you can let people log in with their AOL or their Yahoo or their WordPress or whatever. Okay, and then these are just the original set of APIs. There's actually a lot more than this now. So one of the important things that's happening this year is App Engine is becoming an official product at the end of this year. That means we will not be canceled. Okay, so that's good news, right? So it's a long-term commitment by the company to App Engine, because once we went over 1 billion page views, that caught the attention of a vice president. Okay, you have to have big numbers in order for them to see you. And then they realize, hey, this looks like a good product. It looks like it's going to be making money, so we'll make it official. Okay, so the company is now committed to App Engine, which means the App Engine team can now be committed to its users. And that means that even if the company decides to cancel it, okay, hopefully not, we will keep it up for 3 years before it actually goes away. All right, and then there'll be 3 classes of service. Free, there's always free. Okay, there's always a free tier to try it before you buy it. There's 2 paid services now. So right now, because we're in the trial period, it's either free and paid. Now we'll have 2 different types of paid. So one is per app per month, so about 36 pesos every month for just a generic app that gets pretty decent traffic. If you are a big company, you want more than, you want a lot more apps, you can pay 500 or 2,000 pesos and you can have any number of apps. Also, there's an extra fee if you want special services like a custom SSL. So what does leaving preview mean? So currently, our current prices is here. So you should sign up today while the prices are still low and you have a lot of free apps. But at the end of the year, we were going to go to a new pricing model, which is the formal pricing, official pricing. There's an FAQ if you want to read more about the change in pricing. We will now have a guarantee uptime if you are paid. We will also provide support for the premium class. And then there's also new billing methods like invoicing if you're a big company and you'd like to have that. Okay? So what's the main differences in the pricing? How is the pricing changing? So right now it's like really cheap because it's preview mode, and we're only charging for every cycle you use the CPU. But the thing is, in reality, your app is running on a box, and even if it's not using CPU, it's taking up resources that another app can't run. Right? So we're going to start charging you by, as long as your app is running on the system, whether you're using CPU or not, we're going to charge you for it. So it's going to be a little bit more expensive because we're charging for the extra time. But that's because, it costs a lot of money to run the system, right? We're not trying to make a lot of money off people. It's just we want to get our costs, we want to make sure we don't have any loss in costs. Okay? APIs are currently, like I said, charged by CPU, but now we're going to charge by operation. So if you do have an existing App Engine app and you don't want to be charged this money, you should read this article because it tells you how to optimize your app to reduce that cost. Right? The main 2 things you have to do are 1, reduce the number of instances of your app that are running, and 2, reduce the amount of data store operations that you have. If you cut down on those 2 things, then the cost is not going to be that much different. Okay? It is going to be more, but it's not going to be way more. Okay? All right. Now I'm going to talk about upcoming features. One thing to remember is that we do have features added to the system every 4 to 6 weeks. So it's very hard for me to keep up with what the team is doing. Okay? So here are some of the features we are working on now. So we're, again, going to become official. We're going to provide custom SSL. We're going to have better data store, backup and restore. We're going to have map reduce. We're going to have a searching, so not only text search, but also date search, okay, and other types of searches as well. We're going to upgrade to Python 2.7, and that should be ready before the end of the year. A lot of people are very excited about that one, especially in this community. And better monitoring and alerting. And so you can actually see that, see our roadmap here. And so all of these things are on the roadmap. So one thing I can tell you is that if you see something on the roadmap, that means there's an engineer working on it today. It's not like something we're just going to announce and maybe build later. There actually is somebody doing it right now. Okay. So one of the other things that people talk about App Engine, when they mention App Engine, they always say vendor lock-in, vendor lock-in. So what is that? Vendor lock-in is a system that makes it very hard or impossible to move your app or your data somewhere else. Okay. So does that apply to App Engine? Sort of. Yes and no. You don't get something for nothing. Okay. The main idea is you're taking advantage of Google's infrastructure. You're letting your app run on Google because you want to scale. But the thing is, we built that. It only runs in Google data centers, so it's sort of custom that way. So you kind of have no choice, right? So the price you have to pay is you should write against Google's APIs so that you can take advantage of that that scalability that you can't get elsewhere. It's very hard and very expensive to build scalability. Okay? So, but we still are trying to fight this lock-in thing. So what are some of the ways that we're trying to fight it? Well, we don't absolutely require to use Google APIs. Okay? So for example, App Engine comes with a small web framework called Web App, but you don't have to use that. You can actually use Django, WebDeploy, Bigquery, or Bottle. Okay? Those are also well-known Python web frameworks too. Okay? Data store API. Do you have to write against Google's API? Not necessarily. If you're a Django developer, you can just write against a normal Django ORM. That's the way you would write a regular Django app. And if you use Django non-rel, that actually lets you swap out the backend. You can actually replace the relational backend using Google App Engine. All right. So you actually run your app on App Engine, and if later on you decide, oh, App Engine is not the right thing for me, you can actually take your app, drop it at a traditional host that runs Django apps, and you just have to change your settings that you want. Okay. So it's that easy. So we try not to lock your app in. As far as the data is concerned, we have a bulk loader, so you can easily upload or download all of your data. So we don't lock that in either. If you also want to run your own backend, okay, so if you want to have code that's API compatible, it's client compatible, there's two systems that will actually let you simulate, or it'll run like what App Engine does, but on machines that you do have control over. So if your company is very concerned about uploading to Google's cloud, you can actually build your own cloud, keep your App Engine app the same, because the client SDK, these should be compatible to the client SDK. So these are just backends that you can get. One is AppScale, that's done at UC Santa Barbara. Another one is called Typhoon AE. Okay. All right. Another thing that's important to businesses is security compliance. Okay. So we are certified SAS 70, which is now called SSAE 16, and then ISAE 3402 is the international criminal standard. Okay. So that means we have to follow certain rules. We have to have an audit trail. All right. So we just try to keep everything safe. All right, and the other thing you can do with App Engine is you can interface to other Google Cloud products. All right, so we're coming out with more and more every year. So these other three are, actually these two are live right now. So Google Storage, you can go get a storage account. Okay, it's similar to other offerings from different vendors in the marketplace, but we try to be faster and more reliable. And we also have another API called the Google Prediction API, which is very interesting. It uses machine learning, and you upload your training data, and and what you can do is, after you've uploaded the data and the training information, the next time you upload new data, you can actually ask an API to predict, so which one of those categories is it in. Okay, so it's very interesting. Bigquery is still in preview mode, but that is a Google Cloud thing that lets you upload like terabytes of data and issue SQL queries on it. Because you can't do that with a relational database because there's way too much data. All right, but using Bigquery, you can do that. So using App Engine, you can get access to all these other cloud services. You don't have to use App Engine, but you can. All right, so a few slides on Google Apps. So I don't know if you guys use Gmail or Google Calendar, Google Docs. There's a really interesting integration that I want to tell you about. Not only can you use the existing Google Apps, but you can actually write your own custom applications using App Engine and roll that into your apps domain. So instead of using an apps.com, you'll actually have a Google Apps domain, and all your apps will fall under that domain. So you just opt into it, you add your domain, and then when you go to the control panel of your Google Apps, you can see there's Gmail, Google Calendar, Docs, all these things. But you can also have your custom App Engine app rolled into here for your own company. So if your company, wants more than just what's available, what comes from Google, you can actually write your own. Okay, so that's pretty cool. Now, one thing I don't have time to do today, because we don't have a full tutorial session, is usually I do a hands-on workshop. So we don't have time for that today. So I'll just show you what a workshop would look like, and you can try it at home if you've never played with App Engine before, so you get a feel for it. So if you have a POSIX machine like Linux or a Mac, you can actually use a command line to run the development server and to deploy live. If you're using Windows or Mac, you get a UI when you download App Engine that lets you create apps, that lets you run the development server, that lets you upload live to Google to run on live in production. When you create a new application, you get a configuration file, an index file, and your main controller.py file. So there's just 3, it's not that hard. The configuration file looks like this. You have to have your application name, what version it is, say it's the Python runtime, and then you have a set of URLs as regular expressions, and then what .py files handles those URLs. Okay, pretty basic. Your main.py that's auto-generated is basically the hello world. So you can see this is your main handler. get operation, so it outputs hello world. So you can bring up this app in like less than 60 seconds, pretty quick. And then you just go and modify this, you add more handlers and all that. That's how you get started. Then to run the development server, you can go on the command line. You can click the button in the UI, or you can go to the command line, go development app server, and then the name of the directory where all those 3 files are located. And then you can hit it by going to localhost :8080. You can see hello world. So that demo, like I said, takes less than 60 seconds. If you really want to upload live to Google and run in production, you have to create a real account. So you have to go to appengine.google.com. You have to sign in, and then what you'll do is you have to come up with a unique app ID, and then you'll get this free domain, appid.appspot.com. If you want a custom domain, that's fine. You can create a C name that redirects to this appspot.com. That's not a problem. And then what happens is after you create an account, you have up to 10 applications, and then it tells you what version it's on, and it gives you a list, it tells you how many you have left, and all that kind of stuff. So that's how you create apps. So in order to upload live, you do have to change your application name to something that doesn't exist. Obviously, hello world is already taken, so you have to come up with a new one. Okay. Everything else is the same, and then there's a command line thing that's application config.py, update hello world. It asks you for your email and password, and then it uploads live to Google. And it usually takes less than a minute to do that too. Very quick. And then your app is live to the world by doing .appspot.com. Okay. It's live to the world, except maybe China, because they kind of block us sometimes. So just be aware of that. For your Chinese users, just be aware of that. Okay. Sometimes they can't get to you. All right. So, summary is, App Engine is a platform as a service. It's a hosting service that hosts scalable apps in the cloud. You can use very comfortable environments like Java and Python and maybe Go in the future. And your apps run on Google's high-performance infrastructure. And in its short 3-year history, we have already gotten to 100,000 developers every month, 200,000 apps a week, and 1.5 billion pages a day. It's useful for building both web and non-user facing apps. So mobile, gaming, business, retail, dating. There's a lot of big dating websites. Okay, personals, you know, everybody's lonely, right? Computer programmers are more lonely. Okay. Weddings. We're going to be leaving preview, so it'll be an official product. It'll be formal business pricing, SLA, which is guaranteed uptime, operational support. And again, it's a commitment by the company to App Engine and from App Engine to our users, and we're always adding new features every 4 to 6 weeks. And that's it. Thank you. All right, everybody with us? Let's see.
How do we go into support another database backend?
Are we going to support relational databases?
Yeah.
Okay, so right now, currently, there's no support for SQL databases. It's not Bigtable, which is a non-relational data store. But so there's 2 ways of querying your objects. You can do the object way, which is data equals and then your data class name dot all, which is the more object-oriented way. Or if you have to have SQL, we let you do SQL. We have a subset of SQL called GQL, and you can do something like select star from. So you can issue pseudo SQL statements, but you cannot do joins because that doesn't work with non-relational. What you basically do is you just normalize your data and just have duplicated data. Okay, so that's how it works for now. But in the future, we are considering a cloud SQL product. And if we do have a cloud SQL product, it will also work with App Engine. Okay. So right now it's not SQL, but you can use an SQL syntax. In the future, we will have relational. So the one thing to remember is relational does not scale. So that's why we didn't do that to begin with. So right now we're giving you non-relational scalable. But if you really want relational non-scalable, we'll give that to you too. Okay. Great. Another question? Yeah. Update on the status of full text search support. The update on the status of full text search. Okay, so we announced full text search, I think towards the end of last year, and the latest update. The best place to get the latest update, because I don't know what it is up to today, is the 2 engineers that are working on that gave a talk at Google I/O in May. And if you go to the Google I/O website, you can download the talk and the video. So it's google.com/IO.
And is it possible to map multiple domain names to the same app?
Is it possible to map multiple domain names to the same app? Yes, you can just CNAME as many as you want. And then you can use the host name in the environment variable to figure out which one it is. So you can actually we also have, you can kind of shard your app internally that way. We also support namespaces in your data store so that if you do want to have, if you have multiple customers that are coming in from different domains, you can actually have their data kind of separated using namespaces. So look up namespaces if you want to do that. Okay?
Excuse me if my English is not good.
Oh, it's okay. You can even ask in Spanish and then somebody else will say it in English. Whatever you
I will try in English.
Okay, try good. Try good.
But basically, the cost that you pay is to the store in the cloud and for the store in the cloud and for the hosting. I won't say the APP engine framework is free to download.
Yeah, you're only really paying for resources that you use. Storage, making API calls, having your app running on the machine. Yeah. But the software, it's open source. Yes?
Do you offer a CDN service similar for managing apps?
Okay, so the question is does Google provide a CDN service? So we are not a CDN company like Akamai and things like that, so that's one thing I should tell you. But Google does have a global network because we have data centers around the world, we have users around the world, so we do have a global network. And what we try to do is, we don't guarantee it, but if you set all of your cache headers, if modifies or actually the most important one is cache control. Okay, we will try and cache it whenever possible. Okay, so yeah, but we currently don't provide a CDN service. I know other cloud companies do, but if we feel, we don't. Maybe in the future we'll have it, but right now, just it's optimistic caching. Any others? Okay. All right, great. Thank you. Thank you. Don't leave it. Only to take a picture. So my boss knows I was here and I gave a talk. All right, smile.